Okay, I'm going to show you how to use Singularity to run EDTA. EDTA is a collection of tools that call transposable elements in plant genomes, then filters all these called transposable elements down, and then gives you like a consensus set of good transposable elements in your input assembly. Because it has so many tools inside this package, it's not easy to install by yourself. So there's a Docker image, which you can convert into a Singularity image. It's also on Conda, but today we're going to use Singularity. First of all, I'm going to download the Singularity image. It's on biocontainers, not on Docker Hub, so the URL to download it is a bit different, but this is how it looks like. Singularity pull means download a Docker image or the Singularity image and convert it if it's a Docker image, and then we tell it it's a Docker image. And this is the URL of the currently newest version of EDTA 1.96. This column here shows the version number, so 1.96 is the current version. This will give me an error right now because I just did this because it runs for like 5 minutes or so. I also downloaded the Arabidopsis genome assembly, so we have something to play around with. There it is. Now I have both files. I have downloaded my EDTA image. You can see it's about 1.2 gigs in size. So this contains all the tools I need to run EDTA. So what we're going to do first is create an overlay file system. An overlay file system is a very unique and useful feature of Singularity. What it is, it's a single file that contains another file system. EDTA makes many files, millions of files, and HPC systems don't like that. It slows down the file system for everybody else. Many HPC systems also have file number limits for users, so you might hit these file number limits running EDTA. So the solution for that is overlay file systems. You put everything into this single file. To the HPC system, it's just a file, but to Singularity, it's a file containing millions of files. So this is how you make the Singularity. This is how you make the overlay file system using Singularity. I copy-pasted this from their manual. SingularityExec means run some command. In this case, we're not using the EDTA image I just downloaded. We're using a Docker image of Ubuntu 18 because it has these tools, and EDTA in this example doesn't have these tools. What we're making these two folders called upper and work, which are expected by Singularity's overlay file system. We are making a 10 gig sized overlay file system called my overlay, and we're putting these folders into there, and then we're formatting the file system. This runs for like a minute because I only ask for 10 gigs. In reality, you probably have to ask for more. So for some plant genomes, I had to ask for 60 gigs or so, but then of course it runs longer. So now I have a new file here called my overlay, and it's about 10 gigs, which is what I asked for. So we can access this file system using the shell and the overlay flag. So this means run the shell in Singularity using the overlay file system, my overlay, inside this EDTA container. And now everything is the same, but we can make new folders on the root file system. So I'm making a new folder called files. No error. I exit, and now I'm outside the Singularity image again, and /files doesn't exist. It's only inside my overlay file system. I'm going back into the overlay file system, into the container, and my files folder exists. So what I'm doing now is I'm copying my reference genome into there. So now it's copied into the container, into the overlay file system. And now we can work with that already. We could run our EDTA command now inside the shell, but for HPC, of course, you have to submit your jobs in some kind of a job submission script. So I'm not using the shell now, because EDTA will run for a few hours to days. So inside your job submission script, your EDTA job would look something like this. It's again EDTAexec. So, oops, wait a second. So we have SingularityExec to run some command, -- overlay my overlay, again to tell it where my overlay file system is. We're using the EDTA image I just made, and then we're running some bash command. In this case, I'm cding into my files folder, and then I'm running EDTA with this genome. I made a mistake here because that should be TEA. So this is running now. So what it's done is it cds into files, and because EDTA always writes the output into the current working directory, I have to first cd into files, and then I didn't specify any of the other options because I don't have to do this today. But yeah, it started running now, and it's doing everything inside this overlay file system, and it's not making a million billion files that slow down the HPC file system. They're all inside the overlay folder. The good part, the bad part is that this Singularity run now locks this overlay file system. So while it's running, I can't check what's going on inside the overlay file system. If I try to do that, it'll tell me this container is in use, and I can't look into my overlay. So I'm canceling this job now, and I'm going back to my shell. And I go into the files. So the main job is canceled. I can do this. And ls. And here's all the stuff EDTA has already made in these 1 minute of run. So they're all inside the overlay file system, and they don't count towards your file number quota on the main file system. It's also nice for backup, because once you're done with everything, you can take this overlay file system, these 10 gigs I have, and just chuck them onto storage somewhere. And then the whole analysis, all your temporary files, your input files, everything will be in there. If you check it together with your Docker image, your run is 100% reproducible, because everything is inside this image and this overlay file system. Okay, that's it.